The next example is a structure subject to first one natural hazard and then we'll add one more. So let's read the problem. The bridge is 10% likely to collapse in the event of a flood, and the river has a 25% of flooding during the year. So let's define the events carefully. There are two basic events here. C, the structure collapses, and F, the river floods. The information given for the two probabilities is P of F is 0.25 and P of C given F is 0.1. So we invoke the theorem of total probability. So our partition is F and F bar, and C given F is already known. C given F bar, we assume it is 0. So there is no further information in the problem. So it's reasonable to assume that there is no other hazard. And if there is no flood, the structure doesn't collapse for sure. So that gives us the answer of 0.025 for P of C. And what's being asked, that the probability that bridge will serve at the end of the year. So that's the complement. So the answer is 0.975. Now let's add one more hazard to the problem. So let's add earthquakes. So as you see, we have added the earthquakes in addition to the floods, but there is a simplifying assumption is that the two do not occur simultaneously. So we'll proceed as before. There will be three basic events now. There will be C, and there will be F, and there will be E, which is there is an earthquake during the year. And if you proceed in the same way as before, you will reach the answer 0.9675, that the bridge will not collapse. Now let's add a little more complication to the problem. Here we admit the possibility that the flood and the earthquake can occur together. It's not very likely. The probability is only 1%, but if they both occur together, then the structure is rather likely to collapse. So it's 50%. So now let's carefully interpret the question and let's assign the probabilities. So it would be reasonable to split our sample space into the partition of F bar E, which means there is flooding alone, there is earthquake alone, Fe, so there are both, and F bar E bar, so there is neither. Now what is the probability of Fe bar? My interpretation of this problem would be that P of F is 0.25, but it includes the case where F occurs alone and F occurs with earthquake. So P of Fe bar in my interpretation would be 0.24. Likewise, P of F bar E would be 0.05 minus 0.01, so that would be 0.04. And now if you apply that theorem of total probability, the answer, as I have already given, is 0.965 for the bridge will not collapse.